This is day 3 of Advent of Cyber 2025, and this challenge is called Splunk Basics Did You SIEM? It's almost Christmas in Vail, and the team of the best festival company is busy preparing for the big celebration. Everything is running smoothly until the SOC dashboard flashes red. A ransom message suddenly appears. Attack: 1000 HOPSEC coins for McSkitty, or SOCMUS ends tonight. Message comes from King Malhair, jealous ruler of HOPSEC Island, who's tired of Easter being forgotten. He sent his bandit bunnies to attack TBFC's systems, turn Christmas into his new holiday, Eastermas. With McSkitty missing and the network under the attack, TBFC SOC team will utilize Splunk to determine how the ransomware infiltrated the system, prevent King Malhair's plan from being compromised before Christmas. The learning objectives for this challenge are to ingest and interpret custom log data in Splunk, create and apply custom field extractions, use SPL to filter and refine search results, and conduct an investigation within Splunk to uncover key insights. So for this challenge, there'll be a VM which we need to open, and there'll be a direct URL which we can access within this VM. So we'll start it up, and it should be available to us soon. So we've got our URL here, which we can go to. Okay, so the Splunk instance in the virtual machine appears to have loaded up. So we will continue on with the challenge. So in the Splunk instance, the data has been pre-ingested for us to investigate the incident. On the Splunk interface, click on Search and Reporting on the left panel as shown below. If we go back to Splunk, go to Search and Reporting. On the next page, type index equals main, search bar to show all ingested logs. Note that we will need to select all time as the time frame from the drop-down on the right of the search bar. So in our search, we'll select our index as main, and then we'll change from 24 hours to all time. And then we'll search. After running the query, we will be presented with two separate datasets that have been pre-ingested into Splunk. We can verify this by clicking on the source type field in the fields list on the left, where we should see web traffic and firewall logs. Web traffic, this data source contains events related to web connections to and from the web server, and then firewall logs. This data source contains the firewall logs showing the traffic allowed or blocked. The local IP assigned to the web server is 10.10.1.15. So let's explore the logs, investigate the attack on our servers to identify the culprit. So for this initial triage, we'll be using the web traffic source type. So if we go back to here, we can change our source type to be web traffic and search on that. So search query that's also giving explanation as to what you can see on Splunk. So search query at the top here. This query retrieves all events from main index that were tagged with the custom source type of web traffic. This marks the beginning of the investigation. The top right is the time range. The time range is set to all. Security analysis. This range would be tightened, e.g. to the spike window after the initial data loading. So within Splunk, you wouldn't set the time range to all. You would set it to the actual date range that you're trying to investigate through. Then timeline, which is at the top here. Time range is currently set. This visual histogram shows the distribution of the 17,000 events over time. The graph indicates the successful daily log volume, followed by a distinctive traffic spike, a period of high activity, likely the attack window. Then on the left, we see selected fields. These are the fields currently chosen to be displayed in the summary column of the event list. So host, source, and source type. They represent basic metadata about the log itself. Then there's interesting fields. Interesting fields pane lists all fields that Splunk has automatically extracted or manually added. Fields prefixed with hash, e.g. hash date _ hour, automatically generated by Splunk's time commands. Presence of user agent path in client IP confirms the successful parsing of the web log structure. And then in the middle here, event details and field extraction. This section shows the past details of a single event with extracted fields like user agent, path, status, client IP, and more. So visualizing the logs in the timeline. With your query, you can search for data and then you can pipe it into other commands such as time chart, which will then visualize the data for you. So pipe time chart, and it wants us to set the span to 1 day count, and then we are going to be sorting it by count. Let's run that. This is basically looking at all the logs, grouping them together by the time, and more specifically, grouping them all by days. And once all these logs have been grouped as days, we're doing a count on it, so we can see how many logs were produced on a certain day. But with this, we can then go to the visualization tab and we get the visual representation of when these logs were produced. So we can see there's 5 days here where there was a spike compared to the other days where there was normal expected traffic amounts. Yeah, so currently we're doing just sort on count, but we want to see the highest. So we'll just do a reverse on it, and we can now see October 12th had 2,267. So there is a clear period of intense activity during which King Malheur launches main attack phase. Anomaly detection. Now that we have examined the days with the abnormal logs, using the table in the graph, let's use the same search query to examine various fields to hunt for suspicious values. We need to go back to the events tab to continue. So in here, we'll go back to events, and it wants us to click on the user agent field. And since looking at this image, we can clearly see it's hiding a count amount. That would be an answer to a question. So we may as well take a look at some of the questions. So what is the attacker IP found attacking and compromising the web server? You could probably look at this user agent, select it, go back to events, and see which IP was doing that. So we will go here as well and select client IP, which we can see is 198.51.1.55, which is correct. Which day was the peak traffic in the logs? So if we go back to visualization, that is 2025-10-12 is correct. And then what is the count of the HAVIJ user agent events found? Go back to events, select user agent and 993, and that's correct. We'll now go back to where we were. So upon close examination, it becomes clear that apart from legitimate users like Mozilla's variants, receiving a large number of suspicious ones, which we'll need to investigate further, which was that one. Second field, we'll examine is client IP, which we've already done, and we've grabbed the threat actor's client IP path. Now there was a path. There was a question for attempts at directory traversal, which we currently don't see, but we may need to remove the user agent from the search. So go back to all the logs and let's look at path again. Here we can see attempts at directory traversal through the file equals ... and there are 658. So we'll go answer that. Filtering out benign values. We know King Malheur's bunnies use scripts and tools, not standard browsers. Let's filter out all standard traffic. So let's exclude common legitimate user agents. The following query will remove legitimate user agents from our results and only show the suspicious ones. So we'll just copy this query and paste it in. Basically it's saying user agent must not equal anything which contains Mozilla. Asterisks are wildcard characters, so the user agent can start with anything, end with anything. It just must contain Mozilla. It's done the same for Chrome, Safari, and Firefox. So let's run that query, and it's reduced it down to 7,000 events. And once that field is applied, there's only one client IP present, which must be the threat actors. So narrowing down suspicious IPs. In real-world scenarios, we often encounter various IP addresses constantly attempting to attack our servers. To narrow down on the IP addresses that do not send requests from common desktop or mobile browsers, we can use the following query. So we'll copy this, but first we need to grab the client IP found here and add it to this section. Let's run that, and let's go to visualization. It doesn't appear to... Oh wait, no, I wasn't actually meant to do that. Stick to client IP because it's creating stats based on that field. And then we can see it's just this one IP address with all the log counts. So the results confirm the top IP address used by Bandit Bunnies. In the search query, the dash in the sort dash count will sort the result by count in reverse order. It's the same thing as using the reverse function. So let's pick this IP address and filter out to see what the footprint of the activities captured. So tracing the attack chain. We will now focus on the selected attacker IP to trace the steps chronologically, confirming the use of multiple tools and payloads. Don't forget to replace redacted with the IP we noted previously. So we'll copy this query, place in here, and redacted, we enter the IP address of 198.51.100.55, and let's run that. You can see there are multiple attempts from the threat actor to retrieve .env file, GitHub, git configs, and PHP info. And yes, we can see they're trying to use both curl and wget. They're met with 404, 403, and 401 status codes. So let's search for common path traversal and open redirect vulnerabilities. So copy that query and let's get the IP address first and paste that in. And now let's run the query. So we're searching for path equals asterisk dot asterisk. So basically just looking for directory traversal or path redirect. So the output shows the resources the attacker is trying to access. Let's update the query to get the count of the resources required by the attacker or requested by the attacker. The search query is filtering on the path that contains either // or term redirect. So we will add the stats count on the path. We can see just a list of all the unique paths it tried. So you can see trying to redirect to evil.site, and they're trying to retrieve etc password file. SQL injection, find the automated attack tool and its payload by using the query below. Let's copy this, place into here, copy the IP address, paste OS as redacted, and remove the rest. So we're just looking for requests from this user, and their user agent is SQL map or HAVIJ, and creating a table based on the time, path, and status. So there's lots of requests here. They appear to be trying to manually retrieve items with an ID, but then they're adding commands like sleep 5 seconds, and there's also they're also doing -- to try and see if it's using SQL injection. So above results confirm the use of known SQL injection and specific attack strings like sleep 5. A 504 status code often confirms a successful time-based SQL injection attack. Now let's look for attempts at exfiltration. So it's looking at whether backup zip or logs.tar.gz was accessed or attempted at retrieval or creation. One of those, we'll find out. So they are trying to access it through the path using zgrab wget curl. The results indicate the attacker was exfiltrating large chunks of compressed log files using tools like curl and zgrab and more. We can confirm the details about these connections in the firewall logs. So ransomware staging and RCE. Requests for sensitive archives like logs and config indicate the attacker is gathering data for double extortion. In the logs, we identified some requests related to bunnylock and shell PHP. Let's use the following query to see what those queries are about. Let's copy this, paste it, grab the IP again, put that there, and run the query. Okay, so it's accessing shell.php and trying to run cmd commands. Also trying to access bunnylock.bin file. Seems to be that it's trying to execute it, so it's running chmod and +x to give execution rights. Above results clearly confirm a successful web shell. The attacker has gained full control over the web server and is able to run commands. This type of attack is called remote code execution. The execution of shell PHP, cmd, bunnylock bin indicates a ransomware-like program executed on the server. So correlate outbound C2 communication. We pivot to the search to the firewall logs using the compromised server 10.10.1.5. Let's grab that query and search for any pivoting, and we can see that on port 8080 there appears to be C2 contact from the server IP to the threat actor. Query proves the server immediately established an outbound connection to the attacker's C2 IP on the suspicious destination port. Action equals loud and reason C2 contact field confirms the malware communication channel was active. Now let's look at the volume of data exfiltration which occurred. Copy that, put our destination IP in, which is the threat actor's IP, and run it. So we're looking at the stats, and it's a sum of the bytes transferred. So 126,000 bytes transferred. So results show a huge volume of data transferred from the compromised web server to C2. So identity was found. The attacker was identified via the highest volume of malicious web traffic originating from the external IP. Intrusion vector. Attacker followed a clear progression in the web logs. For reconnaissance, probes were initiated via curl and wget, looking for configuration files and testing path traversal vulnerabilities. Exploitation. The use of SQL map, user agents, and specific payloads such as sleep 5 confirmed the successful exploitation phase. Payload delivery. Action on objective was established by the final successful execution of the command bunnylock.bin by the web shell, and C2 confirmation. Pivot to the firewall logs proved that post-exploitation activity, internal compromised server established an outbound C2 connection to the attacker's IP. Okay, so we've got one more question we need to answer, which is bytes transferred. So 126.167, 126.167, and that is correct. And that is day 3 of Advent of Cyber 2025 completed. Like this video, make sure to like and subscribe.